We are recording, so let's get the slideshow set up from the current slide. All right. Any questions before we get started on anything? Just a few announcements. Sorry about this. We got started on the term. Most of us tried to get our syllabi done and everything else done. And then during our professional development meetings, they said, you got to have the new stuff on the syllabus, and it's on the L drive. And they sent an email saying that. So the next day, when I had a chance in between registering students, while I was still getting things together, went to the L drive, nothing there, that I could tell anything new about the syllabus. So I continue with what they had made a change last year, and I already had those made, so I thought we were fine. Well then, after everybody had the syllabi done, they said, oh, here are the changes. And not just the logo, which I thought they were talking about, they changed things all over it. So I went over a syllabus. The core, the basic stuff, nothing has changed there. It's just some of the other stuff. So you might want to actually go out and look at the syllabus, see the new stuff. They put stuff in about plagiarism. They put it in about conduct. They put it in about all sorts of really important stuff. So it has been changed. So you might want to look at that. I don't know if any of you signed the things already. Not that it's really important, but the stuff about the trig is the same. It's there. Okay. Now, I also changed my locator card because I think the last time we met, I wasn't sure if, well, when I first put it on Blackboard, I thought I was still teaching physical science class. That got taken off, so I've taken that off and adjusted office hours there. So you might want to look at that too. Then the other new thing. I don't know if any of you were interested in WebAssign. Were you? Okay. Second?
I don't think we were.
Okay, I didn't think so either. But maybe for those people who are working at home, if they find it useful, but you too, there is now the WebAssign code. If you bought a new book that came with WebAssign, and a code for you, then you can use that code to register for the course. Okay? I sent a notice on Blackboard, an announcement, and you should have gotten an email as well. Did any of you? You did. All right. So that's done. I want to make sure it went through. Okay. So those are the changes. That's what I did over my extended holiday. Okay. Got all that stuff straightened out. All right. Now, the other thing, and I'm wasting time now, do any of you have any objection to going maybe to 10:55 today rather than 10:45? Do you have an 11 o'clock class?
We have an 11, but it's like right
Okay. Will you? Okay. Be okay? All right. But stop me at 10:55 then. Okay. Or if you need to go earlier, go. All right. We're near the middle of page 262, just below the middle of the page. And we're talking about complementary angles. Oh, your hair is nice today. No, not that time. This is complementary with an E, not an I. What does that mean? Where does that word come from? What word do you almost see in complementary? Complete, exactly. Not complementary with an I, which is saying, oh, what a pretty angle. It's an acute angle, isn't it? No. Okay. These two angles, alpha and beta, are complementary, or they're complements of each other, when their sum is pi halves. Now, what do we call pi halves? 90 degrees. Okay, it's 90 degrees. What name do we give that angle? A right angle. Right. It's a perfect angle. So these complete a perfect angle, a right angle. So two angles, alpha and beta, are complementary with an E if their sum is pi halves. They add to be pi halves or 90 degrees if they form a right angle. Now, you can also have, and by the way, I'm going to insert another word in here. I just said it in jest, but it really goes here. Two positive, notice they have to be positive. You can't have negative 3/2 pi plus 2 pi. That adds to be pi halves, but that's not. They have to be positive angles. The other thing they need to be is acute angles. Okay? Why? What is an acute angle? One that's less than 90. So how can two positive angles add to 90 or pi halves if one of them's already greater than pi halves? It can't happen. So they both have to be acute angles. Now this one down here, two positive, just like above, angles, but these are not acute angles, okay, necessarily, are supplementary. They supplement each other when their sum is pi, the straight line, okay? Now, what can you tell me about those two angles, alpha and beta, for supplementary angles? One is acute, but the other would have to be obtuse, greater than 90. The only exception to that would be if they're each 90 degrees, pi halves. If they're each right angles to begin with, then they are supplementary angles. Okay, so one would be acute and one would be obtuse. But this is the case. All right, so those are the rules. They have to be positive, to be complementary. Both of them have to be acute, to be supplementary, except when they're both right angles. One is acute and one is obtuse. Always. Okay? Any questions on that? All right. Let's do example 2, which they don't show. So let's back up. Goodness gracious, I need to find some white space. I'm not finding any white space. So we'll use this. It's not great, but it's okay. The complement of 2/5 pi. So, okay. You want to name this one alpha or beta? I don't care. Second? Alpha. Okay, call alpha. Okay. Call alpha. Okay. Alpha is 2/5 pi. Okay? What is the complement of that angle? So in other words, what is your beta? The complement of alpha. See, let me do it this way. Alpha complement is equal to beta. Okay. Now what would the beta be? How do we get that? What? Say again? Right. What must be true? What was the rule? The sum is equal to 90 degrees, right? Meaning when you add them. So that means that alpha plus beta is equal to, what are we measuring in now? Pi halves. Yes, we're still in radians. Next slide, we're going to be in degree measure. Right now, we're in that. I know, I think in terms of degrees too. Okay, and we know what alpha is. That's 2 pi over 5 plus beta. We don't know. That's what we're looking for, is equal to pi halves. Okay, yes?
Would it be 1 pi over 10?
Hey, good shot. How did you get that?
Well, I basically double 2 pi over 5.
You did what to it?
I doubled it so that I see how much from halves that it is. And then
Okay. So what? I think I know what you're talking about, but I wouldn't say I doubled 2 pi over 5. You doubled both the 2 pi and the 5, right? Okay, and you made that 4 pi over 10, okay? Plus beta would be equal to
5 pi over 10.
Say again? 5 pi over 10. Okay. Pi halves would be 5/10 pi, right? And now it's a simple means of subtraction. Subtract 4 pi over 10 from both sides. And you're absolutely right. That gives you beta is equal to, those go away. And that gives you, yeah, pi tenths. Very good. Excellent. That's the way to do it. Now, there's different ways you can go about doing it. The book subtracts, you know, and does that kind of stuff. It doesn't matter. But I was using exactly what he did, and that does give you. Now, how about the supplementary angle to pi, to alpha? What must be true there? So now we want beta, let's call it beta supplement, rather than, I should have left beta complement before, okay? What would be the supplement? What must be true there? Yeah, the sum equals pi. So alpha plus beta is equal to pi, and alpha is 2/5 pi, 2/5 pi plus beta, and I don't want to write it as pi. How might I choose to write it? Common denominator? 5/5 pi, right? That is exactly 1 pi, right? And now that's a pretty easy subtraction to do. What would you get? Beta supplement would be, is what?
And the beta supplement would be 3 pi.
Exactly, 3/5 pi. Perfect. Everybody see how that works? Good deal. Good deal. Y'all are good at this. Okay. What if we had alpha being 4/5 pi? You want to do this in a different color? Just so we don't confuse them. What color would you like? Red. Okay, we'll do red. Okay. Alpha equal 4/5 pi. Okay, what is the complement of alpha? So what would your beta be? That would be the complement of alpha. 1/5 pi? Okay, and now I think you're giving me the supplement, aren't you? Say again? Okay, okay. Let me write down, I think beta supplement is going to be the 1/5 pi, pi fifths, right? Because pi fifths plus 4/5 pi, that's going to be the supplement. Yes.
I understand what it is now, but you can keep going.
What's that?
I said I understand what it is now, but you can keep doing what you're saying.
But what?
I said
Yeah.
think I figured it out.
Right.
You keep doing what you're saying.
Okay, yeah. Well, that was the answer for beta supplement, right? Do you agree? Because 4/5 pi plus 1/5 pi is going to be 5/5 pi, which is supplementary angles, right? Do you agree?
Yeah.
Okay. How about complementary angle? I heard an answer given, but I was okay. All right. Yes.
I was gonna say subtracted 3/10.
Okay. Okay. So what you're saying is, tell me how you got there. Alpha plus beta complement must be pi halves. Okay. And alpha was 4/5 pi. 4/5 pi plus beta complement has to be, now, just like we did before, you need to get it in terms of tenths, right? So what would that be? Let's come down here. 8/10 pi plus beta complement is equal to 5/10 pi. Okay? Now what?
I then subtracted both sides by 5/10 pi.
Oh, really? What are we trying to isolate here? What are we trying to find? Beta complement. So we only get this by itself, so you want to subtract that way, don't you? And what do you notice happens when you do? You get a negative. And what's wrong with that picture? You can't do it because they have to be positive angles. Now, what was the deal here? You can almost see it, and it was almost fortuitous. You jump to the supplement, because now you have 4/5 pi plus 1/5 pi gave you the supplement. What do you notice about 4/5 pi? It's obtuse, not. And remember, that was the other word that I said you have to put in there. They have to be acute angles to be complementary. Okay, right? So this one has no complement. No complementary, blah, blah, blah. Angle. It doesn't have one because it's obtuse. It's already greater than pi halves. 2.5 pi's would be 2.5 pi would be pi halves, and this is 4, so that's obtuse. It doesn't have a complementary angle, but it does have a supplementary angle, right? And the other way of saying that, you can't have a negative angle being a complement. They have to be positive, both for supplements and complementary angles. Good deal. Y'all are good at this. Now, there is a checkpoint here, and well worth your effort to do the checkpoint. By the way, I'll remind you, the checkpoints audio-video solutions are available at larsonprecalculus.com. Okay. Now we move to degree measure. Okay, where y'all been wanting to be all along, right? Okay. The second way to measure angles is in degrees, denoted by the symbol degree. Okay, the little superscripted little O-looking shape. It's not really an O, it's actually a symbol that means degree. A measure of 1 degree is very small, okay? It's equivalent to the rotation of 1/360 of a complete revolution around the vertex. Really small, okay. Now, where in the world do we get this 360? Yeah, 360 degrees is one time around. Where did that come from? Probably from, I think if you research this, from the Sumerians. Okay. They were the early Babylonians. Okay. They developed a lot of things in mathematics. And I think time, based on 60 seconds, 60 minutes. I think they had their hands in that. Degrees, 60 times 6 is 360. They had sort of a hexadecimal system, 6 tens, or something like that. Their numbering system had 6 as part of it, okay? I think we can blame it on them, okay? Might be a research paper if you want to consider that, okay? So we're not going into that, but that's just what I've read in the past. Seem to indicate probably the Sumerians to blame for this. To measure angles, it's convenient to mark the degrees on the circumference of the circle, as shown here, very similarly to what we did for radians. And we will come back and make the connections here. But, like you said, if it's 360 degrees all the way around, what's halfway around? 180. And you always hear people, oh, they did a 180 on that. In other words, changed the line completely and went the other direction. Okay? When I was driving, I do that. No. And what's half of 180? 90, our good old pi half, right? And what's half of that? 45. What's a third of 90? 30, 60, 90. And then you can carry that all around. 30, 60, 90, 120, 150, 180. 210, 240, 270, 300, 330, and 360. So that's in 30-degree increments, and 45-degree increments, 45, 90, 135, 180, 225, 270, and 315. I don't remember those very well. Okay, 360. So those are our favorite angles, the ones we like to have as go-to. Okay, and they all come from fractions of that 360. 1/12 of this, which would be half. 4 times 1/3, 1/3 would make this. 4 times that would make this. 1/12 of 360 is a 30. 1/8 is 4 quadrants, and then you split those in 2. That gives you 8. 1/8 of that circle would be then 45, and then multiples of that as you go around. So that's how we measure things in degrees, which frankly we're a lot more used to. At least I am. And this whole thing of radian measures, who came up with that? Was that the decimal people? No, it really wasn't. Actually, okay, no, y'all probably aren't going to continue to calculus, are you? And you probably will be, right? Once you get into calculus, you want to do everything in radians, because your integrals, your differentiation, everything works so much better in radians, okay? So that's why we do it, not those decimal people, okay? All right, so a full revolution, as we already said, counterclockwise corresponds to 360 degrees, half a revolution to 180, a quarter of that is 90, so on and so on. Because 2 pi radians corresponds to 1 complete revolution, and 360 degrees correspond, then this is a ratio. This is a comparison. 360 degrees is the same measure as 2 pi radians, okay? Remember, degrees is a unit. You need to write that. Radians technically is not a unit, but we treat it as if it is. So you could just divide both sides of that by 2 and get 180 is the same as pi radians. Yeah, we know that too. And that is the key for making your conversions. So if you ever have to convert degrees to radians or radians to degree, all you have to remember is this. 180 degrees is pi radians. Just keep that in mind. So, if you had 1 degree, that very little angle there, and you want to convert that to radians, then what you do, you put, I don't like really the way they do it, so let me show you how I do. So let's say we started with, let me get my color back, okay, 1 degree. Now we're going to convert this to radians, okay? That's not really a unit, but it is. Now notice what I did here, and this is how I do conversions across the board, okay? It's my favorite way of doing it. If you have ways you like to do conversions, fine, go for it, okay? But I found this is the most new. Notice I put 2 blanks here. The first blank, and notice there are really 2 entities here. 1 degree is a number followed by a unit, right? And this is blank radians, a number followed by a unit. We're looking for that number. So this double blank here, this blank is for numbers, that blank is for units, right? Now, here's what I do. My rule for doing it this way is always put the units in their place, okay? Don't let them step out of the place, okay? Now, what unit would you put where? Don't worry about the numbers yet. What unit would you put where? If you have degrees here, radians here, one goes on top, one goes on bottom, which goes where? Say again? Radians on top, you're absolutely right, okay? And that puts degrees on the bottom. Now, why do we do that? So the degrees will cancel out, and you're left with radians, which is exactly what you want. Okay? This is how I do every unit conversion I ever do. Inches to centimeters, feet to yards, whatever. This is how I do it. Okay, now. And then what that ratio that I told you to remember? How many radians, how many degrees? 180. Say again? 180. What? Okay, 180 is the degrees. Pi radians, you got it. There are putting the numbers with that. Pi radians is 180 degrees. And that's why then they can say 1 degree. Yeah. And then what you have here, the degrees cancel out, and that gives you pi over 180 radians. And that's how they got this thing. See it? Okay? Let's do it the other way. What if you had 1 radian? Multiply that by a blank blank to give you a blank degrees. What do you do first? Put the units in their place. And what goes where? Degrees on top, radians on the bottom. And what's that ratio? 180 degrees is the same as pi radians. You got it. And then the radians go out. They've been dating. Okay. And we have 1 radian is 180 divided by pi degrees. Okay. Now, just to give us a little bit, and that's how we got this. I would have put the degree sign out here, but that's fine. Okay. Because pi is just a number. It's not really got a unit with it. Okay. So let's get just a general idea here. Pi is just a little bit more than 3, right? So this would be like 3 over 180, which would be like 1 over 60. Okay. So 1/60th of a pi. Okay. So a really small piece of pi. Whereas here, if you do 3, we'll go into 180. That would be 60. So 1 radian is a little bit less than 60 degrees. About 57 something. You know, it's an irrational number, so you can't do it. But a little bit less than 60 degrees. And if you remember back from when we broke that unit circle into, or that circle into 1/6 of a pi, we came up just a little bit short. So yeah, that is a little bit less than 60 degrees. Okay. So here are what they consider their conversion rules. I've already given you mine. If you like theirs better, use theirs. To convert degrees to radians, multiply degrees by pi radians over 180 degrees. Okay? Well, what do we do it? If you started with degrees, put your units in the place. Yeah, that's exactly what you do. Degrees cancel out, and that gives you radians. And to convert radians to degrees, then radians multiplied by something, radians on bottom, degrees on top, 180. Yeah, that's what you do. So rather than remembering the ratio, let the units do the work for you. You know, do the rules there. I hate memorizing things. I hate memorizing formula like that. Always do it this way, because I always get it wrong. I mean, 50% of the time I'll get it wrong. If I get the units telling me where to go, they're usually much nicer to me. Okay. To apply those 2 conversion rules, use the basic relationship. That's it. That's the ratio that you use. Okay? Now let's go back and refresh ourselves. Remember, this was pi, right? Halfway around the circle. So 1/6 of that would be pi 6. How much was that in degrees? 30 degrees. What? Oh yeah, there it is, 30 degrees. Let me show it here. And 1/4 of the way pi, that would be pi 4ths, and how many degrees is that? 45, got it. 1/3, pi thirds, split that pi into 3 equal pieces. How far is that? Say again? 60 degrees. Very good. Get to know these. These are going to be your friends. You're going to use these over and over and over again. And half of a pi is 90 degrees, and 1 pi is 80. How we do that one? And 2 pi, of course, is 360. And you can have all those others in between here as well. You know, and then down here. Just keep using those same ratios and segments. It works. Okay, now, when no units of an angle measure are specified, that means you're measuring in radians. Because radian really isn't a unit, remember? So if you're referring to an angle as 7, it's not 7 degrees unless they have the degree symbol. just says 7, that means 7 radians. So theta equal 2. If there is no degree symbol there, that implies 2 radians. Radian really isn't a unit, it's just a ratio. And the units go out, but we'll put it down as radian. Okay? Always remember that. And in calculus, most of the time we just put numbers down, not degrees. All right, let's do example 3. Now they do it for you. I think, goodness gracious, what's their problem here? Actually, let's do it here. Number 3, 135 degrees. Okay, we want to get that to radians. I always just go on and do this out. What do we do first? Always. Second? Yeah, put the units in their place. What unit goes where? Degrees on the bottom, radians on top. Very good. Because then you cancel out and everything's where it belongs. And then what numbers go with those units? Pi radians are the same as 180 degrees. Okay, so now we're going to cancel our units out. And let's factor out what we can here. Any common factors between 135 and 180? Say again? 45, that's pretty good. 45 will go into 135 how many times? 3 times, excellent. 45 will go into 180 how many times? 4, okay. So that's 3/4 pi radians, okay? Good for them, they got it right too, okay? Let's do 540 degrees. Same deal, folks. Trying to get that to radians. What's the first thing we do? Put what? Radians on top, degrees on the bottom. What numbers match the units? Pi radians are the same as 180 degrees. And now the degrees cancel out. Now, obviously, a real easy thing to do is strike your zeros. Divide by 10. That's easy. Anything common between 54 and 18? 9. 9 will go into 54 how many times? 6. 9 will go into 18. 2. Is that right? Any more? Second? Yeah. 2 will go into 2 once, and 2 will go into 6. 3 times. 3 radians. 500. Well, let's see if that's right. There's 1 radian is 180. 2 radians is 360. And 180 to 360. Yeah, that works. 3 radians. 3 pi radians. Oh, I left off that, didn't I? Ooh, yuck. Y'all were supposed to catch me on that. Okay. 3 pi radians. Don't forget your pi. I never want to forget pi. Okay. I love pi. Okay. Let's just quickly go over and see what they did. Example 3, 135. They did their little thing there. It's so much. I like to do the units thing first, but they did it. They just didn't phrase it that way. And that gives you 3/4 pi. And then 540 degrees, multiply the same thing. Don't memorize the formula, the number, just match the units up, okay? And that gives you 3 pi radians, okay? They're going to skip example 4. So let's us do example 4. Negative pi halves radian is, we're trying to get that, multiply that by blank blank to get how many degrees that is. So what's the first thing we do? Yep, and what unit goes where? Degrees on top, radians on the bottom. What numbers do we write to match those units? 180 degrees is the same as pi radians. And now this is so easy. The pi's cancel out. And what does that, oh yeah, and you can do 2 in the 180 will give you 90. Well, you knew that, didn't you? That would be negative 90 degrees. Yeah, pi halves is 90, so negative pi halves is minus 90. Oh, and I didn't cancel out my radius. Okay. Good. With sound effect. Okay, got it. Okay. Make sense? All right, good deal. Let's do the B part. 2 radians, times blank blank is equal to blank degrees. Trying to get those radians to degrees. So what do we put where? Degrees on top, radians on the bottom. What numbers match the units? 180 degrees is the same as pi radians. This is going to be weird, isn't it? Nothing to cancel out here, so you just multiply numerators, multiply denominators, and that gives you 360 over pi. Now, to get approximate, you can say, well, pi is a little bit more than 3, so that'll be, since it's in the denominator, that makes your number of degrees a little bit less than 120 degrees. Okay? So 2 radians, sure enough, is not 2 single over there, about a little bit less than 120 degrees. All right. And they actually rounded it, and if you've got a calculator, just do 360 divided by pi. Most scientific calculators and better have a pi key on them. So just do 360 divided by pi. I said a little bit less than 120, 114.59 degrees, okay? How they get 5 digits of precision out of 1 digit input, that's a little tough, you know. But I would say about 115 degrees, but whatever. All right, there is a checkpoint if these are a little fuzzy to you, but y'all seem really good on them. As soon as you have a chance, do the checkpoints. All right. Now let's go to applications. Okay, we've already done those. Now, applications. The radian measurement formula, remember it? What is a radian? It's the ratio of the arc length to the radius. Okay, remember that way back? Weeks ago? All right. Arc length divided by radius. Okay? It can be used to measure the arc length along a circle. Guess what we do? Multiply both sides of the equation by r. And that gives you S is equal to r theta. When theta is measured in what? Radians. Don't ever try this if theta is measured in degrees. That formula doesn't work then, okay? Because the degrees is not the arc length divided by radius. That's the radians that are, okay? So for a circle of radius r, whatever you measure that in, the central angle in radians intercepts an arc of length s that's also measured in the same units as the radius is measured in, given by S is equal to r theta, where S and R have the same units, centimeters, inches, yards, miles, whatever, furlongs, whatever. But the theta has to be radians, always has to be, where theta is measured in radians. Now, note if R is equal to 1 radian is going to give you an arc length of exactly 1. S is equal to theta. I'm sorry, I said that wrong. If R is equal to 1, in other words, that's what we call now. When we have a circle of radius 1, we have a special name for that. Did any of you ever used to play a card game that when you got down to one card, you had to say, Uno? Okay. All right. So we call this the the unit circle. Same meaning. Okay. The unit circle. If the radius is 1, it's a unit circle. Then, if R is equal to 1, S is equal to theta. So however many thetas you go around, that's your arc length. okay? Which is rather strange because this is measured in inches or centimeters or furlong or something, and that's usually measured in just the ratio, okay? But the numerical value is the same. The radian measurement equals of theta equals arc length and whatever the length of your radius was, whatever that one measured. All right, so let's do example 5. A circle has a radius of 4 inches. There they drew the picture. Very nice. Okay? Find the length of the arc intercepted by a central angle of 240 degrees. So you're starting from your initial side, which is your horizontal positive x-axis, okay? And then you go 240. That would be 90, 180, so you're somewhere down here in the third quadrant, okay? So how long is that S? What is your formula? S equal R theta. Very simple formula. So do you plug and chug? What's your radius? 4. What's your angle? Oh, really? Say again? You can't use degrees. You got to change the radians first. Very good. So before you do that, get that theta, multiply it by blank blank to give you blank radians. Got to get it in radians first. What unit do we put where? Second? Radians on top, degrees on the bottom. What numbers match those units? Pi radians is equal to 180 degrees. And let's see, I can wipe out the degree symbol, wipe out the zeros. Anything common between 24 and 18? 6. 6 will go into 24 how many times? 4. 6 will go into 18 how many times? 3. So that would be 4/3 pi radians. That's what we plug in for our theta, 4 pi over 3. And that would give you, and this, by the way, is inches, 4 inches. And this is just a ratio, so it has no units. So this will give you 16 pi/3 inches. Okay, now, if you have someone working for you and you figured this out, you said, I need you to take a fence, and how much fencing do you go around here? He's not going to understand 16 pi/3. So, sort of round it for him. This is approximately, remember, pi is a little bit more than 3, so this is going to be 3 over 3. That's going to be a little bit more than 16 inches, okay? With a calculator, you can do 16 pi divided by 3, and you'll get, like the book does, 16.76 inches. That's an approximate, 16.76 inches. I really, sort of bugs me that this has one significant digit, that has 3, but still you're limited here. I swear, I'd say around 17. I mean, how do you get 4 digits of accuracy, of precision, of 1 digit input? You don't. You can't. I'm even stretching it to go 17. But that way, you get a little sloppy to cut off there. Okay. About 16.76, or about 17 inches. Okay. Good deal. Okay. There is a checkpoint there. I would definitely do the checkpoint, folks. Oh, here, they show how they did it. They, of course, use their little formula, which is the same thing we do, but they do it by memory. We do it by reasoning. Okay. At least I think so anyway. And that gave us the same ratio we did before, and that gave us 4/3 pi radians. That's now what we use to enter the formula S equal R theta, and that would be 4 times 4/3 pi. I really like to carry my units with me, and that would be about 16.76 inches. exactly 16/3 pi inches, or rounded up, approximating it about 17 inches, or 16.76 inches. A little more than 16 3/4 inches. How much precision you need. Okay. Note that the units for R determines the units for R theta, because theta is radians, which has no units. It's just a ratio. All right. I don't think we're going to have time to do the next one, so we'll continue next time with linear and angular speeds. All right. Let's see if we got enough done today to do any homework exercises. I think so. 4.1, I've already assigned some of these, either 7 or 9. Do 11, 13. Now remember, all the odd number exercises, number 1, have the answers in the back. Number 2, you can see calcchat.com for tutorial help and worked out solutions for the odd number exercises. So you don't need a code or anything else. That's just a website. You can go to this author, best I've seen about providing these kind of things. Then number 15 and 15 not only is an odd number problem with the answers in the back at calcchat.com, but because it's red, if you got your text, that means it's at calcview.com. So you can, and that gives you more detail, okay? Then on the next group, do either 17 or 19. Both of them are at CalcChat, but 17's at CalcView as well. Then do either 21 or 23. They're both at CalcChat. Do 25. Do 27. Do 29. That's at CalcView and CalcChat. Either 31 or 33. They're both at CalcChat. 33's at CalcView. Either 35 or 37. 35's at CalcView. Both of them. Wait, there is no 37. Okay. Do 35. It's both at CalcChat and CalcView. Then do 37. It's at CalcChat and CalcView. Then do either 39 or 41. Both at CalcChat. Either 43 or 45. Both at CalcChat. Now, they don't show you any examples of these. Shame on them. But try to do 47. Okay? If you have difficulty with it, bring it to class next time. Try to do 49. Again, they don't show you one of these. They just pop it on you. And then 51, finding arc length. We did one like that, so do 51. It's at both CalcChat and CalcView. And then the next one is finding the central angle. We didn't do that, but you could if you know this information. So do 53 and then also 55. And we will, wait a minute. They didn't do any with speeds, did they? Surprise. Oh, no, they will later. They got them sort of out of order. Stop there. We'll do the rest of those next time. All right. Any questions? Now, I haven't figured this one out yet, but I've noticed some of these exercises, in fact, all the ones it looks like that have the red things here, they have this little, it's kind of like a barcode, but what do you call that? It's not a barcode. Yeah, but you can probably with your cell phone do that, and you can probably get straight to it. So if you can go to calcview.com if you're on your computer, or with your cell phone, just go to those and you can see the workout solutions there. Pretty nifty, huh? Okay. Good deal. Sorry I kept you late, but it was worth it because I like to have it. We'll pick up and go from there next time. And maybe we'll have a whole week next week. What a novel concept. Okay.
Did you have fun at this stuff?
No, I stayed inside.
Yeah.
It was so icy, it wasn't really good snow to begin with. Did y'all have good snow?
I stayed inside.
Yeah.
I had hot cocoa.
Huh?
I drank hot cocoa.
Yeah, oh yeah, I did some of that too. I enjoyed that part of the snow. The hot cocoa was tremendous. Good deal. Okay, have a good weekend. All righty.
And we just got back.
Just got back. Have a good weekend.